Hello everyone and welcome to part 3 of the organic question solution for GSI 2022 chemistry paper. So the first question, we have actually been given an alkene bond and Br2H2O as the reagent. So obviously Br2H2 forms H2Br and bromohydrogen formation takes place in this case. So as we know, in conventional bromination, what happens is that bromine Br2 actually forms a cyclic bromonium ion at the alkene first, and then that bromonium ion is opened up by Br minus. So in this case H2O is present. It is also present as a solvent, hence it is in much larger amount than bromine, and thus it acts as the competitive nucleophile here, and H2O actually opens up the cyclic bromonium bridge. So let us see how H2 is actually opening up. So it can open up from this side, but this does not actually happen because water always rejects selectively here, or the nucleophile actually always selectively attacks the carbon, which is more substituted in this case. So the proper way of opening up the cyclic bromonium ion bridge would be as I have shown in arrows in red. So here the cyclic bromonium bridge opens up in reductive fashion and OH forms with the more substituted carbon. After that, in this reaction we have been given H2SO4 and heat. So this actually protonates the OH, it forms OH2 plus, and then the proton in the carbon Br, the carbon containing Br actually falls and the OH2 leaves, and hence we get a C double bond C there once again with the bromine added now in the product. So this is our answer. So second option is the answer to the first question of this part. So with this, let us move on to the second question of this part. So as you can see, we have been given the product in this case and we have been asked to find out the precursor. So let us do the retrosynthetic analysis for this. So if we do the retrosynthetic analysis, we have to find out the bond that can be disconnected. So as we can see here, the CC bond can be disconnected in a fashion where 1,4 conjugated addition might have taken place. So that is the retrosynthetic analysis for this product, and the precursor or the synthon that can do this is basically the same compound, but the COMe and C double bond O are actually on two carbons with a carbon in between, and the in between carbon could have a acidic proton, or I mean not could but would have a acidic proton, and hence that can actually form a 1,4 conjugated attack to make the product. So this would act as a precursor. So let us check the reaction. So we have found out our precursor, so let us draw the precursor first. And okay, so sorry, I have actually drawn one carbon less in the precursor. Let us draw it in a proper manner. Okay, so this is the precursor of our product. So to draw it properly, let us first check the numbering. So 1, 2, 3 and 4, and we can see 2 and 3 has got the double bond and 4 has got the carbonyl group. Okay, so this is the way that they have drawn in the options, so we will also draw in that manner. So those two protons are acidic. NOMe being a base actually abstracts that proton. We have a negative charge there which can actually attack via 1,4 conjugated manner to give us our product. So as you can understand, we have got the answer. So I think the option B or the second option is the answer. So okay, I'll first finish up the reaction. So I've been writing this. So first an annular type of thing would actually form, and which would then actually take up a proton from H2O that is present in the media, and we would get our final product, which is option number B. And this is the precursor. The option number B is the precursor. Yeah. Okay, so let us go to the third question of this part. So this we have been given an oxymercuration demercuration reagent. So HgOH2 MEOH forms the cyclic mercurium ion bridge first in the C double bond C. So here the methyl has been given in the above side, upside. So hence we will first make the bridge in the the below side from the hash side. So we have been drawn with the hashed bond. After that we have been given methanol here. So methanol actually can attack from both sides because both are similar and they are not regioselective. So we can see that so sorry, this one is the B that I am drawing. So this is not option A, but this is B, I mean product B. So OMe forms in the below, and then OMe is in the second position adjacent to methyl, and these are the two products. So NaBH4 after that, then actually does its job. So it has got the hydride H minus and it forms a CH bond in the HGOAC, where HGOAC was present, and hence we get these two as our product. So you can see that option B in this case is our answer. Okay, so let's move on to the fourth question of this series. So this is a similar question. So this has got similar reagent. This is also an oxymercuration demercuration example. So we have been once again given HGOAC whole 2, but there is a twist in this question and it is a very interesting one. So as you can see, we have been given HGOAC whole twice. So first of all, what would happen is that the mercurium ion bridge would actually form HGOAC. Mercurium bridge would form, and after that an intramolecular attack would take place. So OH is already present in the substrate which is actually attacked, and there has been, that is why not given any H2O or methanol or any such thing present in the reagents. Okay, so sorry, I have actually drawn one carbon less once again. So let us just draw it properly. Yeah, so this is what is our happening in the reaction, and OH which is present in the substrate already undergoes intramolecular attack, and that opens up the cyclic bridge. Once again, we also see that OH is actually attacking in the regioselective manner. So the more substituted part is getting attacked, and this would actually give us in a 6-membered ring. So this is also yield a 6-membered ring. Okay, so this is the product that we get, and after that NaBH4 once again does its job, that H minus forms a CH bond, and hence this is the product that we get for this question. So option A is our correct answer. Okay, so let us move on to the next question. Okay, so in this case, as I already said previously, that regioselective attack takes place to more substituted carbon. So remember that during the exams. Okay, so in this question they have asked us which does not serve as Michael acceptor. So what is Michael acceptor? It is basically a 1,4 conjugated carbonyl compound which can undergo an 1,4 attack. So if there is a nucleophile present, so this is actually form an 1,4 attack, and this is how a Michael reaction type looks like. So let us check the reagents that has been given to us in the options. So in the first case, it can undergo. In the second case, we do not see any conjugation, so 1,4 conjugated compound cannot take place. In the third case also, there are 2 ways how it can take place, and in the fourth case also it takes place. So does not serve only in second option. Okay, so let us move on to the next question. So we have been asked to find out the final product, and in the first step we have been given a diene and a dienophile, and heat is provided. So this is the most famous Diels-Alder reaction. So in the Diels-Alder reaction, we first of all do the arrow-processing mechanism, and we can find out the products. We also know that in Diels-Alder reaction, endo product is forms more. Endo product is always major, and both products are formed endo and exo, but endo is major. So in this case, first of all, we will have an endo product for the Diels-Alder reaction. So that actually eliminates 2 options. As you can see, it eliminates A and B. So answer would be in between C and D. Now OSO4 has been given to us, which actually acts as a cis-diol reagent. So cis-diol forming reagent OSO4 forms via osmate ester formation. So first an osmate ester is formed, and after that cis-diol is formed. So as you can see, the ester group C double bond to OMe is already in the below the endo side. So OSO4 would of course stereoselectively come from the above side. So there is no steric hindrance that is being happening in the reaction. So we can actually draw the 2 OH in the cis position from the above side, and that gives us option number D as our answer to this question. So thank you. Let us move on to the next question. So as you can understand that we have been given an unknown compound. So let us first draw a scheme for this so that we can understand it properly. So unknown compound, first of all, is said that it decolorizes bromine in carbon tetrachloride. So if it decolorizes Br2 in CCl4, that means we can infer some information that it has unsaturation present in it. So there are C double bond C present. And another information that have been given is on reacting with warm concentrated KMnO4, which is an oxidizing agent, it forms cis cyclohexane 1,2 dicarboxylic acid and oxalic acid. So let us draw the structures of these 2 compounds. So as you can see that cis cyclohexane 1,2 dicarboxylic acid, so cis side, so let us draw the carboxylic acids on the wedge side and H on the hash side, and plus COH the oxalic acid. So you need to understand that with the reaction with KMnO4, these 2 COOH that are present, that actually forms the C double bond Cs. So I will show you what I am talking about. So this forms the 2 C double bond C of the unsaturation. Hence this is actually our product. So option number C is the correct option. Yeah. So let us go to the next question. So the major product found in the following reaction. Okay, so Br2H2 once again given. So we have done a similar question like this in the previously in this set. So we have been given methyl on the above side and H on the below side, and Br2 is present there. So a cyclic bromonium ion would form as methyl is on the above side. So let us draw the cyclic bromonium ion from the below side so that there is no static bulk. And if it is from the below side, then H2O, which acts as a nucleophile, would of course open it up from the above side. Now already methyl is present in the above, so it would actually attack from the side which is farther from the methyl group that has been given to us. Okay, so Br is in the below and OH is in the above, and this is actually the answer to a particular question. So option B is the correct answer. So as you can see in these, all the options, a lot of permutation and combination they have done, but option B is the correct answer. Okay, so in the ninth question, the second last question of this set, we have been asked which is the most stable intermediate among the following pairs. So pair X, we have been given a carbocation. There is a cation present, and we have OH as one of the functionalities, and in another number 2 we have got methyl as the functionality. Other functionalities are common in both 1 and 2. So as you can understand, if OH is present, then obviously there would be a plus M effect in stabilizing the carbocation. And if CH3 is present, there would be just a plus I effect or an inductive effect in stabilizing the carbocation. As we know, plus M effect is much stabilizer, much more stabilizing than plus I effect because resonance takes place. And inductive effect, which is a very weak field effect, this actually does not stabilize the carbocation as such. And hence, of course, in this case, in this pair, the intermediate 1 is more stable than the intermediate 2. So let us go to the pair Y. Now here we see we have been given a carbanion in this particular pair in 3 and 4, and we have been given NO2 group. So let us see that in both these cases how the NO2 group actually helps in stabilizing the negative charge. So as you can see that NO2 is actually spread out as N double bond O minus, and in the first part, that is number 3, the NO2 can stabilize the negative charge via resonance, but in number 4 the NO2 does not stabilize via resonance. So hence we see that in number 3 there is extended conjugation present for the negative charge to go to the NO2, but in case of number 4 such extended conjugation is not present. So hence we can say that number 3 is more stable than number 4. So 1 and 3 are the stable. So option A is the answer. So this is also a very pretty interesting question, the last question. So as you can see, a good base has been provided to us, and there is a chloride present in the benzene ring. So as all of you can understand, this is ultimately the formation of a benzene. So this reaction is just the formation of a benzene, and as we have got chlorine. So first of all, what happens is that the base actually abstracts the proton which is in the ortho to the chlorine, and this proton is abstracted, and the C triple bond C forms in the benzene ring. So that is the benzene formation, and chloride actually is removed as the leaving group. So hence we get this particular benzene in this reaction, and after that we have got an NHMe, which is a secondary amine, and the secondary amine attacks the benzene, and it actually forms a cyclic compound in that particular part. So as you can also say that the minus charge gets the H plus, so it actually takes the H plus from the NH plus that was actually forming. So yeah, so that is the mechanism. Okay, so let us check the second reaction that we have been given. So X is, we have got what is X. So let us go to the second reaction. So you can already see that only in option D is this particular formula given. So option D should be our answer. And so let us check with the Y also. So as you can see that here also a benzene is formed. So I'm sorry, I have shown the arrow mechanism in a wrong manner. So first of all, the H ortho to the Cl would actually be abstracted by the base, and after that Cl would leave to form the benzene, and once again the similar attack ensues, and this similar attack gives us a similar product for Y also. So X and Y are actually same products in this particular question. So you, even during the exam, if you have got a time crunch, you do not have to go for the whole mechanism. You can directly answer option D in this particular case via the elimination process, because X is already that particular formula. So thank you for listening, and as I always say, practice hard and you do good. Thank you.